All right, let's do the unit circle now, special right triangles. We haven't talked about 45, 45, 90. We've done 30, 60, 90 for a couple of days here. So let's talk about 45, 45, 90 and see if you could answer these questions that come with it. And I hope this isn't too bad. But first, I'm going to turn this paper over. This is in Canvas if you want to look at it. And I need to remind you what you already know or already have been taught from Integrated 2. If you've forgotten, hit that. There we go. So on a 45, 45, 90, what you have learned is both legs are the same. So if you know one, you know the other. That's cool. And you may or may not have remembered. Let me just write the number 3 here, just for argument's sake. This would also be a 3. That to go from one of the legs to the hypotenuse, there was a shortcut. And that shortcut was to multiply by the square root of 2. Multiplied by the square root of 2. And that was always going to work. So whatever the legs were, if you multiplied by the square root of 2, you could get the hypotenuse. Now, you did a bunch of those probably, but what made this one harder is what we have to do. And luckily, we only have to do it one time. So after we do it, you don't have to go through what we're doing. But let me put a number here before we get to the one we're doing. Let's say we're talking about the number 8, and I give you the hypotenuse was 8, and I asked you to find this leg. Of course, both legs are the same, so it doesn't matter which one you find, and you're just trying to go backwards to try to find a leg. Well, if going from a leg to the hypotenuse is multiplied by square root of 2, how do we go to a smaller side? How do we go backwards? That's right. It's divide by square root of 2. So both of these guys would be 8 divided by square root of 2. Now, somewhere in your math career, you might have had a teacher that said a square root in the denominator is actually not allowed. It's frowned upon. It's illegal. And we used to teach how to make this legal. But for your trig pre-calculus class, I think this one's going to be okay. So I'm going to leave this alone right now. If you get to a trig pre-calc teacher or college teacher that says we need to get rid of this radical symbol in the denominator, then there'll be a process to get rid of that. But I am not going to mark this wrong right now. Now, the only triangle that we do in this class is this one. On the problem I just wrote, I had an 8 right there. In this class, it's a 1. This is the only one we do. So once we do it, you don't have to do it again. So how did we go from the longest side to the shortest side? It was divide by square root of 2. And since that is 1 over root 2, this guy's 1 over root 2. I feel like I should show you, and I'm gonna. To make this legal so that you know, and you don't have to do this every time. If you just watch right now, this is the only time we're going to do it. We multiply this fraction by a fancy form of the number 1. And that fancy form of the number 1 is root 2 over root 2. Does everybody agree that that's equal to the number 1, anything divided by itself? So why did we pick that? Well, when you multiply a fraction times a fraction, the rule is to multiply straight across, right? So 1 times root 2 is just root 2. Root 2 times root 2 is root 4. Don't write root 4 there. What's the square root of 4? What's the square root times itself there? Yeah, it's just 2. And see, this guy, which we're going to write in our class, is the same as this guy. They're the same. If you don't believe me, watch. On. Clear. 1 divided by square root of 2. And then square root of 2 divided by 2. Identical. One's just considered legal, but I don't care. Okay, so we're going to use this guy. Now, here's the cool thing. Both legs are the same. So when we put a 45, 45, 90 in a unit circle, this is your answer. Or this is your answer. It doesn't matter whether it's sine or cosine. This is your answer. But with a twist, you have to know whether it's positive or negative. The other cool thing you can see from this diagram here, when you start from 0 and you head counterclockwise, 30 degrees was the first special triangle you come to, then you come to 60. So for a 30, 60, 90, there are 2 triangles we could put here in quadrant 1, right, where it's manipulated. There's a 30 and there's a 60, and they're both 30, 60, 90s. They've just been twisted. But there's only one 45, 45, 90 we can put in this triangle right there. Because if we go another 45 degrees, we're up here at 90. If you go another 45 degrees, you're at 135. So that means this angle here, called the reference angle, would be 45 degrees. If we go another 45 degrees, we'd be at 180. Another 45 degrees, we're at 225. Another 45 degrees would be at 270. The next 45 would be at 315. And then another 45, you'd be all the way around at 360. So if you look at what I circled, 45, 135, 225, and 315, those are the only 45, 45, 90s in this unit circle. And you're going to tell that it's a 45, 45, 90 because they're the ones that end with fives that I'm going to give you. All the other ones, they end with zeros, but those are for 30, 60, 90s. Okay? So I know that was confusing. Let me dive into the ditto. The ditto is also on Canvas for you to look at. That means that going around a circle, like we just did, there's only 8 different questions, right? For 45 degrees, I could ask you for sine or cosine. For 135, I could ask you for sine or cosine. Sine or cosine, sine or cosine. So there's only 8, and all 8 of them are on this ditto. So at some point, you would just be doing them over and over and over repetitionally. So the first one I got here is 45 degrees. It's up to you to know where that is. So I head this direction, and 45 degrees is the very first angle we come to, 45 degrees. That's special. Make your triangle. Remembering that the hypotenuse you just drew is 1. That means both of these legs are 1 over root 2. Both of them. Sine is x or y. Do you remember from doing the 30, 60, 90s? Sine is the y value. And the y value is this side here. So it's 1 over root 2. The only thing you got to worry about, is it positive or is it negative? And going up, is that positive or negative? Going up is positive. Watch what happens. So I've already punched on there 1 divided by square root of 2, which is that decimal here, right? Watch what happens when I hit sine 45. Same decimal. So sine of 45 is equal to 1 over root 2. We're just staying away from our calculators and staying away from these decimals. We're typing that fraction instead. All right, let's head to B. 225 degrees. So where the heck is that? If I head around the circle counterclockwise, there's 90, right? Here's 180. So if I've gone 180 degrees, how much more do I need to go in that same direction? And the answer is 45 degrees more. So I just went 45 degrees past 180 degrees. That gives me 225. Make your triangle. This guy's where the 1 would go, which means these guys are the 1 over root 2. Because we went to the left, it's negative. Because we went down, it's negative. So both of these are negative. So cosine, which is the x value, and the x value is this guy right here, is negative 1 over root 2. $135, where is that? Starting at 0, heading counterclockwise. Here's 90 degrees. It's right here. Right here's 180. So 135 has to be between those guys. How far between? Well, if you've gone 135 degrees this way, how much is this angle right here? How far from 180 degrees are you? And it's 45. So that's 45. That's a 90. This would be 45. The hypotenuse is 1. This is 1 over root 2. This is 1 over root 2. This is going to the left, which is negative. This is going up, which is positive. Which one do I want? Cosine is the x value, and the x value is the left or right fella, so it's negative 1 over root 2. All right, so if I just go double check here, cosine of 225, that was the problem number 2 we did. Check and see how that's negative 0.707, which is the 1 over root 2. We just did cosine of 135, and you'll notice the answer is exactly the same. That's why the answers we just got in B and C were exactly the same. Okay, so I think I'm going to let you try this. All of the answers are 1 over root 2. It's just, is it positive or is it negative? That's why you got to get yourself in the right quadrant and then know, is it asking for x or is it asking for y? And is the x positive or is the x negative? Okay, so all of your answers to the remaining 5 are 1 over root 2. You just have to know, is it positive or negative? All right, hope that made sense. Hope you guys have a good weekend.